Yeah. So it's your divisor. So when you write this remainder, you put your remainder, which is m minus 1, divided by your divisor, which is this m squared minus 5m. Okay. This is the final answer. Let me look at it. 4m squared minus 3m plus 1 plus m minus 1. Yeah. So this is the final answer. Okay. Take that first example I did. Do your best to reproduce it. Once you get that one, then move on to the next example. You know, but you can't skip. You know, everything is based on your understanding the previous one. So I presented it in a manner where you need to take it step by step, case by case, make each one make sense. Take the time to do that. I'm actually going to keep going. I know it's kind of going over time, you know, but I'm just going to give you the full lecture. That's one of the luxuries I have. I have 10 minutes officially left on the clock, but I'm probably going to go over. It's a new system, you know. We're just going to keep moving. So that was example 4. I'm going to move into example 5. Divide this by this. Okay. X cubed, this by this. X squared. I think I'm gonna give you example 5, but I'm gonna leave it as an exercise. I'll give you the problem and I'll give you the answer. If you ever want me to go over it at another point in time, I will. But otherwise, I'm just gonna leave it as an exercise for you. So example 5. All right, we're given divide 8x cubed plus 21x squared minus 2x minus 24. Minus 24. Divided by 4x plus 8. Okay. So divide the 8x cubed plus 21x squared minus 2x minus 24 by 4x plus 8. And the answer you get here, do the same steps as I've been doing before. You get 2x squared plus 5 by 4x minus 3. Okay. So if you follow the same steps, you should get to something that looks like this. Fill in the gaps. Okay. All right, so that's example 5. Actually, we are actually finishing right on time. I have a little notation and then one more example and we're done. So I'm not going to hold you over long. Dividing. So next is just a little notation. Yeah, just a little table. This is dividing functions. Dividing functions. If f of x, let's see, so if f of x and g of x define functions, then this symbol here, f over g of x, all this means is f of x divided by g of x. Okay? the domain of the quotient function is the intersection of the domains of f of x and g of x. It's the intersection of the domains of f of x and g of x, excluding values of x for which g of x is 0. Why? Because whenever you have a fraction, you never want that bottom to be 0. So your domain is just going to be, you find the domain of f, you find the domain of g. Take their intersection and be clear about what do you mean by their intersection, you know, just do that. And then, so it's going to be the intersection, but you'll also have to throw out anything that makes g of x 0. Okay? So any x value that makes g of x 0, you have to throw those answers out. Okay, let's see if we can reproduce this. Okay. All right, so this is the last example. Then have a good weekend. All right, so example 6. Example 6. You're given f of x is 2x squared plus 17x plus 30. You're given g of x is 2x plus 5. We need to find f divided by g of a negative 1. Okay, find f divided by g of negative 1. Alright. So when you see this symbol, f over g, so you have f divided by g. Now what I want you to do, don't find the negative 1 first. Find f divided by g of x. Okay, find this first. And then once you simplify it down, plug in negative 1. Okay? So this f divided by g of x is equal to f of x divided by g of x. So that means we have, this is, what's my f of x? So I have 2x squared plus 17x plus 30. Where'd that go? Okay, let's try this again.